Okay, so for this one here, we've been given the equation. We need to solve for a and b, and we're given the vertex. So we have two variables, but we've only been given 1 point. That's going to be kind of hard to solve for. However, we have to remember that the vertex is not just any point. It's the same as 2 points almost, because it tells us the symmetry. So if I want to set this up, I could do this in a few different ways. So I'm just going to sketch this out. So one thing I do know is the y-intercept. Okay, so if I sketch this out, -4, positive 56 is way out here, 24, the y-intercept is here. And I know that there must be a symmetrical point over here somewhere. And I'm going to have my parabola go through that symmetrical point. Something like that. Okay, so that's at 24, 0, 24. That's at -4, 56. And I could find that coordinate. In fact, I know that coordinate's going to be just twice as far from the y-axis. So it's going to be -8 and positive 24. Okay, so that because I know the vertex, it tells me symmetry. So I have more than 1 point. So I could set this problem up and solve it like this. I can just find two equations given these two coordinates, the vertex and this other coordinate that I just found. So I'm just going to do equation 1. Y is 24 when x is 8. So I get 64a minus 8b plus 24. Okay, so I end up with 0 equals 64a minus 8b. I'm going to simplify that. 8a minus b equals 0. Okay, so that's one equation. I can come up with a second equation by plugging in 56. Okay, and when x is 4, -4, I get 16a minus 4b plus 24. Okay, so I end up with, that's going to be subtract 24, so that's going to be 32 is equal to 16a minus 4b. Divide everything by 4 to simplify that equation. Okay, so I end up with 4a minus b equals 8. Okay, so I have my system of equations. I'm going to take equation 2 and subtract it. Okay, so if I subtract, I get -8 equals 4a plus 0. So b's cancel out. So a equals -2. Solving for b, I'm going to back substitute it into here. So I get 8 equals -8 minus b. I think that's right. Okay, so b is equal to -16. Okay, so my equation looks like this. It's going to be y equals -2x squared minus 16x plus 24. Okay, so that's one way we can do this problem. Now, we could have also switched this around and said, well, I have a vertex and a point. I can work this out in vertex form. So I can just say the vertex form is going to be, and this gives me only one variable to solve for, which is kind of nice. Okay, so plus 56. And then I need to solve for a by plugging in the 24. Okay, when x is 0, I get 16a plus 56. Solving for a, so I get -32 equals 16a. A equals the same, -2. Okay, but now I have this. I've just had to solve. This is not a system of equations. There's only one variable to solve for here. Whereas this one, if I keep it in general form, I have two variables to solve for in a system. So if I solve this, I get y equals -2 x plus 4 squared plus 56. That's the same equation but in different form. So if I want to solve for b, I just expand this and combine like terms. So I end up with x squared plus 8x plus 16 plus 56, and then multiplying that out. There's my negative 16 for b. Negative 32 plus 56 is plus 24, which I already knew from the original equation. Okay, so there's two ways to do it. You can, this one, if you use the vertex form and convert it into the general form, you only have one variable to solve for. So that's kind of a nice solution to this. Otherwise, you have to set up a system of equations, and to do that, you need to have another point. So I have to use a symmetry of this graph to be able to generate the second coordinate, this one here, so I can have two equations, two unknowns to solve for a and b.